In these examples, it's examples for solving equations. We know it's an equation because it has an equal sign, so that means we can solve and find out a value for the variable that would make this equation true. Whenever I'm solving an equation, I remember kind of an acronym, SAM, check, and that is the order in which I'm going to do things. So the first step was simplify each side of the equation. The second step is use the addition property to eliminate terms on different sides of the equation. And the last step is to use the multiplication property to multiply or divide by the coefficient, the number in front of the variable, so that I can isolate or get the variable all by itself. Finally, I can also go then and check my answer back in the original equation. So in this first problem, it asks me to solve the equation 6m plus 11 equals 35. When I look on each side of the equation, there's nothing I can do to simplify, so I'm going to go to the addition property. I focus on the side of the equation that has the variable, and I want to first leave the variable term where it is and eliminate anything else. So I can see I'm eliminating that plus 11. So to undo an addition, I would subtract 11 from both sides. I have 6m, 11 minus 11 is 0, so I just get 6m equals 35 minus 11, which is 24. There's no more addition property, so now I move on to the next step, multiplication property. That is how I get rid of the coefficient, or the number that is being multiplied by m. So to get rid of the number 6 that's being multiplied, I would do the opposite multiplication, or divide by 6, and I do the same to both sides. And I end up with m equals 4. If I wanted to go back and check my problem, I could do a check where I start with my original equation, and I substitute in the value m with the number I got, 4. So I have 6 times 4 plus 11 equals 35. And I have to put a little question mark here to say I'm checking to see if that's true. 6 times 4 is 24 plus 11 is 35, and that does indeed equal the other side. So if those two sides turn out equal when I do that evaluation, I feel confident in my answer. On example number 2 here, B, I again start with, can I simplify something on either side of the equation? And this is just a number. The right-hand side has two terms, but they're not like terms. One has a k and one's just a constant, so I cannot simplify. So I move on to my next step, the addition property. So I'm focusing on the side with the variable. I am going to leave the variable term itself alone and get rid of anything else. So I have a positive 4 as my other term, so to get rid of the positive 4, I'd have to subtract 4 from both sides. On the right-hand side, I'm ending up with this, it was minus 2/3 k, it just becomes a negative 2/3 k. And on the right, I have negative 2 minus 4, and I can evaluate that and make sure I'm careful with my sign rules. Negative 2 plus negative 4 is negative 6. So now that I've done the addition property and I have one term on each side, I can work on getting rid of this coefficient. So to get rid of a 2/3, I would divide by 2/3, in fact negative 2/3. And when I divide by a fraction, that's the same as multiplying by the reciprocal. So I'm going to multiply both sides by negative the reciprocal of 2/3, 3/2. And I'm doing the negative reciprocal, the negative sign here because there was a negative sign here. So I want negative times a negative to be a positive. So on the right-hand side, everything cancels out except the k, and I just get k. On the left-hand side, if I'm multiplying a fraction by a whole number, I can put the whole number over 1. And so I have negative 3/2 times negative 6 over 1. 2 goes into 6 3 times. Negative times negative is positive. 3 times 3 is 9. So I end up with k equals negative 9. Again, I could check it in my original equation. So if I want to go back into a check, in for k I'm going to substitute in the value 9. So negative 2 equals 4 minus 2/3 times 9. And then I will go ahead and evaluate that. So negative 2 equals 4. Let's see, 2/3 times 9, I can put that 9 over 1. I can do canceling, a factor of 3. So I have minus 2 times 3, or minus 6 over 1. So negative 2 equals 4 minus 6, which is the same as 4 plus negative 6, or negative 2. So sure enough, that answer checks, so I feel confident with my solution. Let's look at one more. On this third example, I do have something I can simplify on the left-hand side. There's something that can be distributed, so that would be my first step. Distributing is like doing a multiplication, and I would do that before I would do this addition and subtraction over here. Inside the parentheses, those weren't like terms, so there wasn't anything to do to combine. So I'll distribute my negative 4, and so I have a negative times a positive is a negative 12x, and I have a negative 4 times a minus 6, so it would be like a negative times a negative gives me a positive 24. And again, if you like to, you can change this subtraction to plus a negative to really see I have a negative times a negative, giving me that positive. So I have plus 11x equals 2. I have like terms, negative 12x plus 11x. Negative 12 plus 11 is negative 1, so just negative 1x plus 24 equals 2. No more to simplify. I've combined like terms, used my distributive property, so now I'm ready to move on to the second step, addition. So again, I want to keep my variable term and get rid of anything else, so I'm going to get rid of this plus 24 by subtracting 24 from both sides. I end up at that point with the opposite of x, or negative 1x, equals 2 minus 24. And again, I can think that through, which is 2 plus a negative 24, negative 22. Remember, when I have the opposite of x, or I can put that 1 in to remind myself it's negative 1x, I'm not quite done yet. I need to get a positive x to be done solving, so I'm going to have to still get rid of that negative 1, so I can divide both sides by negative 1. That way I get positive x equals negative divided by a negative is a positive 22. And then if I wanted to, again, I could go back, rewrite my equation, and check my answer.